Okay, so we're continuing our solving our system of linear equations, right? Remember that this was our revenue function and this was our cost function. So we're setting them equal to each other because we want to know where they intersect, right? These lines are basically intersecting at a specific point. So this is a nice equation from chapter 6, a linear equation, right, of degree 1. So if we solve this guy, well, we can bring 100x, right? You can do this in your head or write it out since you've been practicing a lot. So we have $100,000 is equal to 200x, right? So 200 times what is $100,000? Well, you can divide both sides by 200,000, right, if you want. I mean, that's what you're really doing to find x. And right, these guys are gone. I mean, technically you don't need a calculator. So it's just really half of 1,000, which is 500. So x is equal to 500. 500 what? Dollars, bikes, like what are we talking about? Well, remember that in the beginning, x represented the number of bicycles we're going to produce. So this means that there's 500 bicycles. Okay, so if there's 500 bicycles, then that are produced and sold, right? What's the cost, right? So let me just move this up a little bit, or what's the revenue? So in this case, oh, I forgot what color I did it was red or blue, but I think I want to say my revenue was blue. Okay, so remember R of x is equal to 300x, but we know what x is, right? What's our input? R of 500, right? This is the function notation that we've been working with. Function notation. And that just means, right, 300 times, I should probably make that blue. 300 times what? Well, x is 500. So 300 times 500 is 150,000, right? And this is dollars because we're talking about revenue. So this guy, right? Let's see. So R of 500 is equal to 150,000. And let me just move this up. And remember, right, this means this is my x, 500, and this is my y, right, my input, and here's my output. Okay, so this is the point of intersection if you graph these two functions, which happens to be this break even point, right, which we will describe in just a bit. But overall, I mean, this is what we've been doing, right? We've been solving systems of linear equations. So we've been solving for x and y. So we used the math to solve this application. So what does so in part C it said determine the break-even point, right? And describe what this means. Well, let me move this up. And so I will write it, and then I will, okay, so just so I can make sure I see everything. This means when 500 bicycles, right, are produced, right, that's produced and sold, right, both the cost and revenue, right, our C of x and R of x, revenue are $150,000. Okay, so that's what that means, the break even point, right? Or as the book likes to say, so 500 bicycles reveals, right, the number of units or bicycles that a company must produce and sell so that the money coming in, right, the revenue is equal to the money going out. So you're not at the break-even point, you're not making money and you're not losing money, okay? You're literally breaking even. So I'm gonna, if you graph this on your calculator, I have a graphing calculator and I just punched it in just because it's a little bit hard to scale this. Whoops, I didn't want that. Let's erase that. Let's see, how are we doing? 5 minutes. Let me move this up. So this is just a quick sketch. Okay, so we only need the the first quadrant. Okay, so remember the x-axis, right? This represents the number of bicycles, right? Number of bikes, right? And then our y scale, right? That's our dollars, right? Our money, our $150,000 cost and revenue. So maybe I'll scale this at, let's just say that's 50,000, right? 50K, 100K, 150K, and maybe 200K. And the bicycles, I don't know, let's just say this is, 200 bikes, 400 bikes, 600 bikes. And again, this is, where's my arrow? There's no graph paper. It's a little bit tough. Maybe actually I'll do it on graph paper after this, but I just want you to see the picture here. So if you graph, well, let's see, what's our point? So 500 is right here, right? 500 bicycles. And let's see, 150,000, right? So see if I can draw this straight, right? The two lines should intersect right there, right? So that's the break-even point. Now, if we graph our revenue function and our cost function, right? Notice they're right here, right? 300x, well, even right here, 300x, and here's our revenue function and here's our cost function. Okay, so 300x, that's y equals mx plus b. Well, let's see, that was, I think, the blue. So if I, graph it, right, again, this is a quick sketch. Pretend we don't know that's the point of intersection. This is our r of x, and our cost function, c of x, right, is 100,000 plus 100x. Well, 100,000k is right here. That's the y-intercept. And we're going rise over run, so we're going up 100. But remember, this is $100, not 100,000. So it's really, I mean, if I, zoom in here again, this is like, let me zoom in more, right? It's, a little 100, rise over run. It's a small little staircase. So, whoops, let me zoom back out. And again, if you graph the line with pink, this is what you get. And again, there's the break-even point. And I want you to notice what happens if X, right, if the number of bikes, what if you produce and sell more than 500 bikes, right, or less than 500 bikes? Well, here's 500 bikes, right? If you keep, if you sell more, right, this is all gain. So let me maybe graph or shade this. Right here, you're making money if you sell more than 100 bikes. If you sell less than 500 bikes, right, this is really loss. You're losing money. So maybe all this piece, right? So if you sell, 200 bikes or 300 bikes, this in here, this is really a loss. So again, example 9, very similar. Hopefully that makes sense. And yikes, it's 9:25, 9 minutes and, 30 seconds. Okay, I'll stop here so it won't take too long to upload. Okay, hopefully that made sense.